Okay, Jai Hind guys. So welcome to Deshpande Coaching Institute. So as you all know, we are recording the series for 10th standard, which is science and for maths. So maths, I will be taking geometry as theorem and also algebra. Now you will get to know the further updates. Now the science series will be starting from lesson number 1, which is gravitation. So Miss Aditi will continue. So she is Miss Aditi. If you have any doubts, comment down on the video.
Hello students. So I'll be continuing the science series for 10th standard. So today we'll be covering the first chapter, that is gravitation. So we all know who discovered gravitation, right? So Sir Isaac Newton discovered gravitation. As we all know the story that apple fell on his head and then he discovered the gravitation force, which is the force by which earth attracts all the object towards itself. So we'll today learn what is the universal law of gravitation that Newton has stated. So let us assume that these are two bodies having mass m1 and m2. We can assume that this is a marker and it's the cap having mass m1 and m2. So there is a force of attraction between these two objects as well. So what is this force exactly? So Newton has given a universal law for this existing force. So there is a gravitational force between these two bodies m1 and m2, and the distance between these bodies is d. So Newton has stated that the force is directly proportional to the product of the masses of the two objects. Okay, so it is directly proportional to the product. Directly proportional, which means increases. So the force increases with the masses, and it is inversely proportional to the distance square between these two objects. So if d is the distance between the object 1 and object 2, then the force is universally proportional to the distance. Universally proportional means when the force increases, the distance decreases. Okay, or when the distance decreases, the force increases. So whenever this distance decreases, the force will increase, and whenever the masses will increase, the force will increase. I hope you understand direct and inverse proportion. So to remove this inversely proportional sign, this proportionality sign, we generally introduce a constant which will replace this sign with a equal to sign. So in our case, that constant is nothing but the gravitational constant, or which is also called as the universal gravitational constant, which is nothing but g. So we introduce here g. So the formula becomes force is equal to the universal constant of gravitation into m1 into m2 upon d square. So this is the final formula for Newton's universal law of gravitation, where F stands for the force between the two bodies, G for the universal gravitational constant, m1 and m2 are the masses of the two bodies, and d is the distance between the two bodies. Okay, whenever in exam they can give you the mass of the two bodies and the distance between them in meters. If it is in centimeters, you convert it into meters and then solve. The value for g is fixed, then you can easily find the force. If they have given force and mass of one object, you can easily find the mass of second object using this formula. You have to just substitute the values and then we can get the force. So the value, which is 6.67 into 10 to the power minus 11 Newton meter square per kg square. So you have to remember this value. So every time a numerical comes up, we have to substitute this value. So now how does this unit come? So the force, the unit of force is Newton, the unit of mass is kg, and mass into mass becomes kg square, and distance is in meters. So meter square becomes this, and if we calculate it for g, then the unit becomes Newton meter square upon kg square. Okay. So I'll take one simple numerical. We'll consider that the mass of the body is 5, the mass of second body is 2, and the distance between these bodies is, let's say, 1 meter. Okay, so what will be the force? So the force will be 5 into 2 upon 1 into g. G is 6.67 into 10 to the power minus 11. So you have to calculate this, which is nothing but 5 into 2, 10 into 6.67 into 10 to the power minus 11. Then it becomes 6.67 into 10 to the power minus 10. So the force is Newton. Don't forget to write the unit. So this is the answer. So it's a pretty simple example to find the force by the universal gravitational formula. Okay. So now we'll study the 3 laws of motion given by Newton, which will be very helpful to solve the further numericals. So these 3 are the basic, or we can say fundamental equations, which everyone should know. So the main terms in these equations are displacement, velocity and acceleration. So what is exactly displacement? So let us consider that you go to the school from your home by taking a certain route. Okay. So let's assume that you have your home here and your school is here. So you take a path like this and you arrive at your destination. So this is the total distance covered by you. It can be 1, 2, 5, 2 meters, 1 meter. So the total distance will be 3, 8, 10. So the total distance is 10 meters. So this is the distance. But what is the displacement? Displacement is the shortest distance between the 2 points. So I draw a straight line and this is the displacement. So this is the basic difference between distance and displacement. Distance is anything. We can use any route to go from this point to this point. But this straight line is the displacement. Okay? And generally in the equations, displacement is denoted by S. Velocity is denoted by V. And acceleration is denoted by A. So you have to keep these nomenclature. S is for displacement, V is for velocity, A is for acceleration, F is for force, and T is for time. Okay. So we'll study the 3 basic equations. So first equation is V is equal to U plus AT. I hope so this is visible to you. V is equal to U plus AT. So now V is the velocity, but here V is the final velocity. U is the initial velocity of that body. A is the acceleration and T is the time in seconds. So what is final and initial velocity? So V is the final velocity in the sense, if I throw a ball from this height or if I throw this marker, the initial velocity U of this object is 0. It has no velocity. But when I drop it, its velocity will increase. So that is the final velocity. So initial velocity in most of the cases is 0 because the object is at the rest. So this object is in my hand. So it has 0 velocity. It is not moving. So initial velocity is 0 and final velocity will be the velocity with which I will drop this. Okay. So this equation is clear. The second equation is S is equal to UT plus half AT square. So all the nomenclature in this equation are clear, I guess. S is the displacement, U is the initial velocity, T is the time plus half AT square. A is the acceleration as T is the time square. And S is displacement. So when we have to find any displacement in any problem, we use this formula. when we have the initial velocity, acceleration and time. So going for the third equation, it is v square is equal to u square plus 2as. Okay, so here v is the final velocity, u is the initial velocity and a is acceleration, s is displacement. So whenever we have acceleration, displacement and initial velocity in the problem, we can easily find the final velocity using this formula. So we have to keep these equations in our mind. These are the basic fundamental equations which we will use in solving the further numericals. And few more basic formulas are v, velocity. The formula for velocity is displacement upon time. Okay, so whenever we are given displacement, we can find velocity by this. So velocity is displacement divided by time, and speed is equal to acceleration is equal to velocity upon time. So this goes like that. So first initial is displacement. Displacement is denoted by s. So initial is displacement, velocity is displacement upon time, acceleration is velocity upon time, and speed is distance upon time. So in every formula, the denominator is the time. So everything is divided by time. That is, every quantity is the derivative of time. So remember, velocity is displacement upon time, acceleration is velocity upon time, and speed is distance upon time. I hope you know the difference between displacement and distance by now. Okay, so we'll be using these formulas for solving our next numericals and also these three fundamental equations. We'll solve the sum numerical which will cover all the equations that we have studied. So let's start by reading the numerical first. So this numerical states, an iron ball of mass 3 kg is released from a height of 125 meters and falls freely to the ground. Assuming that the value of g is 10 meters per second square, we have to find first the time taken by ball to reach the ground, then the velocity of ball on reaching the ground, then the height of ball or at half the time it takes to reach the ground. So we have to first find the time, then we can find the rest of the things. Okay, so let's first mark what is given. So mainly we can see mass 3 kg is given, then height which is nothing but the displacement s is given, and g which is gravitational force of acceleration 10 meters per second square. Okay, so first we'll write given mass is equal to 3 kg, s is equal to 125 meters and g is equal to 10 meters per second square. G is nothing but a, acceleration. So acceleration and g are equal, as g is the gravitational force of acceleration. Okay, so whenever they give us the value of g, we have to assume that this is a. Okay, then now we'll start solving the example. So first we have to find the time taken by ball to reach the ground. So from the three fundamental equations, we'll take the second equation of motion from which we can find the time. So the second equation of motion was s is equal to ut plus half at square. So from this we know the acceleration, we know the displacement, and we have to find the time. Now you will see that the u is not given in equation, but as I told you, u is the initial velocity which is mostly 0. So the ball when dropped, it doesn't have any velocity. So the initial velocity is 0. So we'll consider u to be 0. So if we put the values 0 into t plus 1 by 2 into 10 into t square, and s is 125. So s is the displacement of the ball when it is dropped, and so we consider the distance, the height or the distance from which the ball is dropped, we consider it as displacement s. So now if we solve this equation, this term turns out to be 0 and we get t square is equal to 125 upon 5 because 2 5s are 10. This 5 will come here and t square is equal to 25. Therefore, t is equal to 5 seconds. Don't forget the unit. The unit is very important. So, t is equal to 5 seconds. So, we have calculated the time needed for the ball to reach the ground. So, now what do we have to find? Second is velocity of ball on reaching the ground. So, which is the final velocity v. So, we can calculate it by using the first equation. And first equation is v is equal to u plus at. So, in this we have the time, we have the gravitational force of acceleration. U we already know that it is 0. So, we can find the final velocity. So, u is 0 plus 10 into 5. So, final velocity is 50 meters per second. So, unit of velocity is meters per second and don't forget to write the unit. The third thing we have to find the height of ball at half the time it takes to reach the ground. So, half the time. So, we have got the time to reach the ground is 5 seconds. So, half the time is 2.5 seconds. Now, we will consider time is 2.5 seconds. Why we have made it 5? Because we have given it in the problem. Okay. So, the height of ball. So, we will again use this equation to find the height, that is the displacement. So, S is equal to ut plus half at square. This time we will put t as 2.5. So, S is equal to u is 0 plus 1 by 2 into 10 into 2.5 square. So, we get S is equal to 31.25 meters. So, the unit of displacement is meter because displacement is nothing but the height from which the ball is dropped. So, the unit is meters. So, the distance for this time is 31.25. So, to calculate the height of ball at half the time to reach the ground, we have to subtract this value from the original height. 125 minus 31.25. So, you guys calculate this answer and this will be the final answer for the height of ball at half the time which it will take to reach the ground. So, comment down the final answer in the comment section and thank you.